Hello, welcome to this video. This is 4-3 and today we are going to look at contextual problems involving rates and answer questions about said rates. Alright, so go ahead and looking at the notes. Previously looking at Unit 4, we have looked at units in context and we've interpreted those derivatives in context, as well as use derivatives involving straight line motion to answer questions. Now what we're going to do is, using those concepts together, answer questions about other derivatives in other contexts. Alright, so without further ado, here is example number 1. And example number 1 says, Speedville High School opens its doors for students at 8 a.m. each morning. One particular morning, the number of students inside Speedville High School can be modeled by the function p of t, where 0 is less than or equal to t is less than or equal to 8 minutes since the doors open at 8 a.m. Find the rate, here's what they want us to do, find the rate that the number of students inside Speedville High School is changing at 8:03 a.m. Alright, so looking at this, they give us P, and that's the number of students inside Speedville High School. Well, if I want the rate that it is changing, that is P prime of T. So what we're going to go ahead and do is we're going to take the derivative. So 25 times the derivative of the natural log of 3t plus 1 times the derivative of the inside, which I can go ahead and clean up to be 75 divided by 3t plus 1. So there's my derivative, and we want to go ahead and find out, well, how's it changing at 8:03? At 8:03. Well, this function p is minutes after the doors have opened at 8 a.m. So if I wanted at 8:03, t is equal to 3 minutes. So I'm going to evaluate p prime at 3. And when I plug this in, we get 75 over 3 times 3 plus 1, which gives us 75 divided by 10, which is 7.5. And the units, remember, P is talking about students, 7.5 students, and our time unit is minutes, so students per minute. Okay, so we want to interpret this in context. What does it mean in context? Well, the number of students inside Speedville High School, that's the context, that's what P represents, is, and what is it doing? Is increasing at a rate of 7.5 students per minute at t equals 3 minutes, or at 8:03 a.m. Okay, so we have answered their question and in context. Okay, remember, whenever it's asked you what the rate is, you want to talk about what it is in context. Say if it's increasing or decreasing, include at a rate of, include those units, and then as well as state what the independent variable time is. Okay, these questions, the rate questions, often on the AP exam are calculator active. They come in the first or second free response question. So here, example 2, we note that this is a calculator active problem. And it says for 0 is less than or equal to t is less than or equal to 10 days, the rate that a company sells t-shirts in hundreds of shirts per day on its website after an appearance on Shark Tank is modeled by S of t. At what rate is the rate of the t-shirt sale on its website changing at t equals 5 days? Okay, well, if this is the rate that a company sells t-shirts in hundreds of shirts per day is modeled by S of t. Okay, we want at what rate is the rate of the t-shirt sale on the website changing? at t equals 5 days. Okay, well, then I want S prime evaluated at 5. Okay, it's calculator active. I'm going to save my mind and my time by using a calculator. So I'm going to go ahead and open up a new document and a calculator, and I'm going to go to derivative at a point. Now, if this was an actual AP exam question, I would first define that function, and because I'm probably going to have to use the function more than once, but here I'm just using it to answer this question. So I'm evaluating at 5, and the function that we have is 124e. Make sure you use the exponential button and do not type e. It will give you a syntax error. To the power of -2, and I didn't use t, I've been using x, so I'm going to make sure I change that variable, and I'm going to have to approximate. There we go. So there is our value, about -0.011259 approximately, ... Okay, and we want to go ahead and answer this question in context. So what does this mean? Well, what does S of t mean in context? Well, that's the rate of t-shirt sales. T-shirt sales is, and what is it doing? Is it increasing or decreasing? Well, it's negative. It is decreasing at a rate of 0.011259 hundreds, because remember it is in hundreds of shirts per day. That's what S of t is in, right? Remember that's a rate. S of t is in shirts per day, and then we just took the derivative of that, so it's per day again, per day, and you could say shirts per day squared at t equals 5 days. Okay, and then there is our context. Awesome. Okay, example number 3. It says, a rumor is spreading around school that Mr. Passwater once placed 3rd in the world's strongest man contest. The rumor is spreading at a rate, so here they give us the rate, of dr dt, where r of t is the total number of students, that have heard the rumor, and t is the number of hours since the rumor began. So they want to know, is the rumor spreading faster when 200 people have heard it, or when 400 people have heard it? Okay, well, the number of people who have heard the rumor is r of t. Well, I want to know, how is the rumor spreading? So that is r prime, okay, of t, r prime of t, which is the same thing given as dr dt, okay, and that's given. So what I'm going to do is I'm just going to evaluate. What is r prime of 200? What is r prime of 400? And then we're going to compare those. Which one is faster, is bigger? So here we have 1/4 r, that's 200, times 500 minus 200. I just plugged in 200 for all those values, and we get 200 times 300 divided by 4, which gives us 60,000 divided by 4, which is 15,000. Okay, and I'll calculate with 400. 1/4 400 times 500 minus 400. So this gives us 400 times 100 divided by 4. So 40,000 divided by 4, which gives us 10,000. Okay, and again, the units on these, this is students per hour, so students per hour, okay, and so which one is it? Which one's faster? Well, it looks like r prime of 200 is more. So we're going to go ahead and say the rumor is spreading faster when 200 people have heard it. And our justification is because r prime of 200 is greater than r prime of 400. Okay? So comparing rates is one question that the AP test will ask you. Okay? And they often say justify or explain. And here's our justification, okay, along with our work. All right. Next, example number 4. This is a practice problem. I would like you guys to go ahead, please pause video. I want you to try number 4, and then I'll go ahead and go over the problem here in a moment. Give it a go. Alrighty, hopefully you have done this problem. Now, I highlighted some key information. They define the domain from 0 to 5,000, and they say the total amount a local college spends on printing is modeled by C of S. So I have C of S, where S is the number of students enrolled at the college, and C is the total cost of printing in thousands of dollars. And they say, at what rate is the total cost of printing changing when 2,500 students are enrolled? So if I want to know when the total cost, how the total cost is changing, I'm going to take the derivative or the rate of that. So C prime of evaluated at 2,500, and that gave us with the calculator 0.0151, and that is thousands of dollars per student. So our conclusion: the total cost of printing is increasing at a rate of 0.0151 thousands of dollars per student at S equals 2,500 students. Okay, so hopefully you got that. Hopefully that was very, very straightforward. Okay, next, example number 5, and this question is eerily similar to a question on the AP example, or the AP exam this last year, 2022, asking about cars at a toll plaza, or here it's a toll road. Okay, so example number 5. For 0 is less than t, which is less than or equal to 10 hours, the rate cars enter a toll road in cars per hour is modeled by C of t. So that's the rate cars enter the toll road. During this time, cars exit the toll road at a constant rate of 200 cars per hour. That is their exit. Is the amount of cars on the toll road increasing, or is it decreasing at time t equals 9 hours? Okay, so the amount of cars that enter, that is C of t. So what I want to do is I'm going to evaluate, okay, how many cars are entering this toll plaza at 9 hours? So that's going to be 400 minus 5 times 9 minus 2 squared. So we have 400 minus 5 times 49, which gives us, what is that? That's 5 less than 250, 245. 400 minus 245. So we have 155. So 155 cars are entering per hour. Cars per hour. Okay, and the amount, I'm just going to call this E of 9. They're exiting at a rate of 200 cars per hour. 200 cars per hour are exiting. Okay, so is the amount of cars on the toll road increasing, or is it decreasing at t equals 9 hours? Well, I have more cars leaving, so that would be a decreasing amount. That would be decreasing. So I'm going to go ahead and say the amount of cars on the toll road is decreasing is decreasing by a rate of 55 cars per hour. At t equals 9 hours. Okay? And if they ask for justification, like explain why, well, that would be because c of 9 is greater than, or is less than 200. Okay? All right, last example that I have here is example number 6, and here they give us a graphical representation, which is kind of neat. They say, at a local library, visitors check out and return books throughout the day. The rate that visitors check out books in books per minute is modeled by L of t. So here is L of t, and this is books being checked out. Books out, okay, and that is in books per minute. This is in minutes, and this is in, I'll call it BK per minute, books per minute, where t is measured in minutes. During this time, the total amount of books that have been returned to the library, total amount of books that have been returned to the library is modeled by total amount of books returned, modeled by R of t, okay, where t is measured in minutes. Okay, so here this one's interesting because they give us a rate of books going out, and then they give us a total. Very interesting. All right, so here they say, at what rate are books being checked out by visitors? At what rate are they being checked out by visitors? At t equals 9 minutes. T equals 9. Well, if I want the books being checked out, I'm going to go to my graph. I'm going to look at 9. And I'm going to go up to my graph right here. And it looks like 5. It looks like 5. So 5 books per minute. This is L of 9. L of 9 is equal to 5 books per minute. All right. B. Is the amount of books at the library increasing or decreasing at time t equals 6? At time t equals 6. Well, I can figure out the amount of books leaving, L of 6. So I can go to my graph and I can say, okay, at 6, how many books are leaving? And that looks like 3.5 books per minute. Books per minute. That's the amount of books leaving. What about the books coming in? How many books are coming in? Well, I have a function for the total amount coming in, for the amount of books being returned. But if I want to know the rate at which they are leaving, I'm going to go ahead and analyze what is r prime of t. I need the derivative that they are being returned. So the rate that they're being returned, derivative for t is 4. So this is 4 books per minute. And thus, that's a constant function, right? So if I analyze what is r prime of 6, that's just going to be the same thing. So 4 books per minute. Okay. And then what's our conclusion? What's our conclusion? Well, I have more books coming in than I do leaving. So thus, the amount of books in the library is increasing. The amount of books at the library is increasing. At a rate of 1/2 book per minute at t equals 6 minutes. Okay. C, at what time is the books that are checked out equal to the rate that books are being returned? Well, the return rate, r prime of t, is equal to 4. So I want to know, okay, when is the books being checked out equal to the amount that they're returning? Okay, so just looking at our graph, I want the rate to be 4. So I'm going to draw this imaginary line, this secondary function. Here's our return rate. It's 4. And when is it equal to the rate that they're leaving? Well, right here's an intersection, and right here's an intersection. So it looks like 5 and 8 at t equals 5 and 8. T is equal to 5, 8, right? And this is when it is equal to L prime, or sorry, just L of t. When is it equal to L of t? That's what we found out. Okay, so I'm going to go ahead and say the rate that books are checked out is equal to the rate books are being returned is at t equals 5 and 8 minutes. There you go. All right, hey, we answered a whole bunch of questions on this about rates in context. It's important to remember to talk about the rate, what it means in context, not just in terms of y values, but in terms of x values or t values at what time, and then also indicate if a rate is increasing or decreasing. Give me a thumbs up if you like that video. Subscribe for more awesome math videos. I'll see you in the next one. Peace.